I'm over here at Bryant's, going to get the crank in it tonight. Check those main bearing clearances. We're going to talk about Plastiguage a little bit. You know, like I was saying, Richard normally sets everything up, but since I use the Loctite on the bearing spacers, we know it's going to modify it just a little bit. We know it's going to probably be just a tad tighter. We don't know how much tighter, so we're going to verify it. And we're going to use Plastiguage since I don't have all the tools that he has at the machine shop. So check it out. Let's see what we got. Okay, so crankshaft's in the block. Don't have any oil on it. Got the bearings all in the caps. They're in the block, so they're ready to go. With the Plastiguage, it's pretty simple. It's pretty easy. You know, they got different sizes for the clearance. 2, 3, 4, 5, 6 on the reds. And then the green is 1 thousandths, 15 thousandths, 2 and 3. So that's as much as it goes up to. And you just check the squash on it. With the bearings installed in the block, install the crankshaft. And then install the bearing in the cap. Put the piece of cut Plastiguage on the crankshaft and assemble the cap to the block. Torque it to spec. After torquing, loosen the bolts and remove the main cap. This is when you will compare the width of the Plastiguage. The amount that it squished will determine the clearance. Compare it to the chart on the Plastiguage. The goal on this motor, usually, you know, 3 to 3.5 thousandths, somewhere in there is about where it's generally run. So with the Loctite though, and the spacer bearings this time is a little tighter. So you can see in all of it. That's the main cap. The one's coming up. And you see it's pretty consistent. You know, some of them are very difficult to see. You kind of see it down in there. Oh, there you go. The shine on those new bearings. And you see it's real consistent. Most of them are about the same. So when you do the clearance, I got 1.5 thousandths on the very front one up here. But all the other ones are about 1 thousandths. And all you do is you take this little, once you bolt it in there, you take the caps off. Don't turn it while it's in there. And then you simply, this chart here. And so the chart, it's pretty simple. So you just spread it across there, and is it 1 thousandth or 1.5 or 2 or 3? So depending on how fat it is, how much it's crushed and spread out, that's going to make it, you know, appear to be tighter. So that's going to make it tighter. So all you do, I mean, it's pretty simple. So let's see if I can show you what I did. So right there. So you can see when you adjust those, you put it on there. So since I want about 3 thousandths, it would be, you know, only about that wide, and it's not. So you just go on down. There's 1.5, and there's 1. So that one is, the front one here is in between the 1 and the 1.5. But then if you go back down to some of these, on the back, that one's closer. That one's a little closer to 1 thousandth. So I mean 1.5 thousandths. So and then I've got another one over here. They got a couple different thicknesses that you can check, and so this one will go just a little bit higher. So this red one will probably be the one I use next time. I mean, it's in thousandths increments instead of, you know, half thousandths. But so we're on deck. I just sent Richard a message earlier. Hopefully this week he can polish it up. I mean, I guess it's possible we could do it by hand with some Scotch-Brite on the bearing, but taking off 2 thousandths on each one, that's a lot. So I'd rather him just polish it out of the crankshaft. And so we're going to do that and get it all back together. Hopefully this week we'll have a running short block. Okay, we're back at the shop, part number 2. Just got the crank. So Richard ended up having to put it in the crank grinder. He said he didn't feel like polishing it was going to be as accurate. So he knocked 1/1000 off of it. So we're about to stick it back in the block. Got it in the block now. Going to go ahead and remeasure it with the Plastiguage and see what kind of numbers we come up with. Let's hope it's good. Alright, so you can see we got the Plastiguage on it. It is a lot better. It's still not quite as loose as what we normally run, but I think it'll be okay. We got somewhere between 2.5 thousandths. It's kind of hard to see it again, but there is the Plastiguage up close. And that's, you know, up close shot to it. So that measures out between, you know, 2.5, 3, probably closer to 2.5. So I think it'll be fine. I might have to run a little bit thinner oil in it. I generally run the Bryant 2050, so we may end up getting it a little thinner weight oil. But we're gonna try it. I'm about to oil it up now. Crank the shaft back out. Put some assembly lube on it and turn it, torque everything down, and see how it turns. Another thing to make sure you check without any oil in it is the thrust. You want about, I like about 10 to 12, 15. This one has got about 10 or so in it now. And thrust clearance is simply that clearance there. You can hear it sliding back. Once you get oil in it, then you can't really move it as easy. So that's always something to check. And you know why you got the crank in there dry. Alright, got some good news. All the mains are torqued down, and it spins. And I use the Lucas for assembly lube. A lot of people use, real assembly lube. You know, this a little thinner, so it spins with a little less drag. But I have, for the last probably 10 or 15 years, I've always assembled it with just Lucas, just the normal heavy-duty oil stabilizer. That stuff is the bomb. I would use it for everything, it seems. So you can see down here where I was talking about the thrust a little earlier. I made sure to set it, I always do the main cap last, torque all the front ones down, and then on the back one, you want to make sure the crankshaft is contacting the thrust bearing on the upper bearing, on the one in the block, and the one on the cap. And you can see down in there is my thrust, and it still moves a little bit. The Lucas makes it a little more difficult, but it does move. You can kind of hear it slopping the oil. But so that's good. Always make sure, you know, on a small block Chevrolet, you got the rear main seal down in there in the back. Now this one is since it had a 400 main and it had to have a line bore to get that, it uses a special rear main seal in the dark Iron Eagle block. Ask me how I know that it's special. When you put the wrong one in, it leaks like a sieve. So we done that several years back. Put it together, thought we had it all together and solved the oil leak, and put the wrong seal in it, just put a normal 350 seal in it, and it leaked like crazy. So I had to pull the transmission out twice. Was not happy about that, but learning experience. So there again, this thing's good. So hopefully tomorrow night I'm gonna get over here and have a assembled short block. The pistons are on the rods, and the rings are already done, and they're on the pistons. So realistically, a couple hours worth of work. I'm hoping tomorrow night, my goal tomorrow night is to get the pistons in it and go ahead and get the camshaft back in it, and possibly go ahead and degree the camshaft. And then I'll have a closed short block. Then I got to do a little bit of work, got to do a little bit of massaging, welding on the oil pan, since it broke to pieces. It wasn't too bad though. I've had a lot worse, so it shouldn't be too bad. I don't know if it's going to have fire in the hole this weekend or not. We're doing our race at Galot on August the 1st, that Thursday night. So, I mean, that's, you know, a week and a half away. So I'm into short rows now. I got the head back, so I've got to put the spring back on the head. Actually in pretty good shape here. Don't forget to like, comment, and subscribe. See y'all next time. Hopefully we'll have an assembled short block. Thanks for watching.